We really need to do something about this object because we just got the clearest images of 3I Atlas ever, and the details from these observations once again break some of the fundamental rules of comet physics. What's more, Harvard astrophysicist Avi just published a new analysis, and he reveals some more weird things that science can't seem to explain. We're seeing tail structures that probably shouldn't exist at this distance from the sun. We're measuring brightness levels that contradict all predictions, and the geometry of what's happening is showing significant problems with the standard thermophysical model. So in this video, I'll explain what's really going on with 3I Atlas and why it's so weird right now. Comet 3, I Atlas, is currently about 186 million miles from Earth, which is about twice as far as the Earth is from the Sun. But before we get to the mass loss or the dimming, the latest images are stunning astronomers by seemingly breaking some of the fundamental physical rules of how comets work. In this November 22nd image taken by an amateur astronomer using a half-meter telescope, a device capable of gathering much more light than conventional small telescopes, 3I Atlas appears to have a violent halo around its nucleus. From it extend two distinct structures, the comet's tails. One tail points away from the sun, stretching for 3 million miles, while the other, which turns in the opposite direction and toward the sun, is about 600,000 miles long. Most puzzling of all, both tails are unusually thin, concentrated, and irregular, like bands of material that are squeezed together rather than spread out. The November 24th image, taken when the comet was only 15 degrees above the horizon, which is difficult to observe, still shows the strange structure intact. Independent observation teams around the world saw the same phenomenon, eliminating the possibility of artifacts or equipment errors. So what is keeping these jets collimated like laser beams, stretching for millions of miles, instead of spreading out like every other comet ever recorded? Some researchers are starting to wonder, is 3I Atlas being affected by an unusual magnetic field, an unknown form of jet, or even a completely new physical mechanism that humanity has yet to decipher? These structures that do not obey the traditional rules are making 3I Atlas one of the most mysterious comets observed this year. So what makes one tail of 3I Atlas 5 times longer than the other? The standard tail pointing away from the sun makes perfect sense, since radiation pressure and the solar wind naturally push matter in that direction. But the other tail, the anti-sun tail, is a paradox. It has to fight head-on against forces so strong they can erode the planet's atmosphere. Each particle in the anti-tail is like trying to swim upstream in the stormy ocean of the solar wind. To survive its 600,000-mile length, the anti-tail must have an extremely high density. According to Loeb's calculations, the anti-tail's mass density must be about 1 million times higher than the solar wind, a number that far exceeds any form of outgassing observed in comets. This is not just unusual. It raises a whole new scientific question. What creates jets of material so heavy that they can penetrate the solar wind and still maintain their shape? Moreover, this 5-to-1 ratio has not changed. Previous observations have shown similar results, suggesting that the mechanism that creates the two tails, one normal and one retrograde, is remarkably stable over hundreds of millions of miles of space. No comet has ever maintained such a stable, asymmetric jet structure for such a long time. Normally, comets fluctuate wildly as different pockets of ice are exposed to sunlight during their rotation, causing their brightness and gas flow to change constantly. But 3I Atlas once again defies the rules of familiar physics, as if there is an entirely new energy mechanism or interaction behind it, not described in any previous comet dynamics model. Before discussing the unusual brightness, it's worth returning to a more fundamental issue, the rate at which 3I Atlas is losing mass. Comet tails are formed from material vaporized by the sun's heat, a phenomenon called sublimation, where ice turns straight from solid to gas. But at a distance of 186 million miles, 3I Atlas's surface should be so cold that it's almost frozen, making it unlikely to be as active as it is now. To put that into perspective, let's look at the numbers. The sun radiates energy to every square meter at any distance in the system. In 1 hour, the sun supplies Earth with more energy than all of humanity consumes in a year. At Earth's orbit, That's 1,300 watts per square meter. But when you move back to 180 to 186 million miles, that energy is only about 300 watts per square meter, a radiation so weak that it would be unlikely to be enough to wake up any distant comet. What's more, most of this energy is not used to heat the ice. Comets reflect a large portion of sunlight, and the absorbed energy is released mainly as infrared radiation, making the sublimation efficiency very low indeed. For carbon dioxide ice, the main volatile in 3I Atlas, the sublimation temperature is minus 78 degrees Celsius, and only a small amount of the available energy contributes to ejecting material from the surface. Based on the radiation intensity at the current distance, one can calculate the exact amount of ice sublimated per square meter per second. Avi Loeb did the math, and the results are staggering. To generate the mass loss rate observed in the November images, 3I Atlas would need 620 square miles of active surface area, all sublimated at full efficiency, a near impossibility for a small, cold body less than 200 million miles from the Sun. This raises an inescapable question. What is activating 3I Atlas beyond what standard physics allows? Is this just a rare coincidence of surface structure, or is it a completely new mass loss mechanism that science has not yet described? But then NASA unexpectedly released new images from the Mars Reconnaissance Orbiter taken in early October, and 3I Atlas appeared as a soft, glowing white sphere. The image showed the comet's dust and gas cloud measuring about 1,500 kilometers in diameter, a giant halo floating in space. But the solid material actually involved in the sublimation process was much smaller. Based on previous measurements, the comet's nucleus was only a few kilometers across. Its total surface area was only about 66 to 76 square kilometers. Even assuming that the solid core accounted for a large portion of the outer mantle, the actual sublimation surface area was still far less than the 620 square miles needed to account for the loss of material. In other words, the math doesn't add up. Given its surface area, it's impossible to create that much mass from just the ice vaporized by the Sun. According to conventional theory, this would only make sense if the comet had broken into multiple pieces, a situation that often occurs as it approaches perihelion, where tidal forces and high temperatures cause the structure to break down. More pieces mean more surface area, which in turn increases the rate of sublimation. But the November 11th image tells a completely different story. 3I Atlas appears to have a single intact nucleus with no trace of debris, no detached dust cloud, just a single solid object. This leads to the controversial conclusion: the available surface area cannot explain the observed mass loss. Once again, 3I Atlas behaves as if it doesn't follow traditional physics models for comets. What's really going on under that glowing crust? We may be witnessing a form of celestial behavior that science has yet to name. But the latest images reveal another strange anomaly. Comet 3. I-Atlas is much brighter than normal at this distance after passing the Sun. Currently, comets follow a predictable brightness curve. As they get closer to the Sun, they heat up and become brighter. After passing perihelion, they move away from the Sun and cool down. Their brightness gradually decreases in a predictable way based on their distance. Atlas 3I has been moving away for over a month now. At a distance of 180 million miles, the heat from the Sun has decreased significantly. The activity should be decreasing, and therefore the brightness should be fading. However, the November images show a strong and sustained brightness. The comet cloud is still glowing brightly. The tail structure is still prominent and distinct. There is no sign of the expected fading. Harvard scientist Avi Loeb has calculated that to maintain this brightness, the object must be losing about 200 tons of matter every second. This is a huge rate of continuous mass loss for an object that should be cooling and quieting down. If 3I Atlas has been losing 200 tons every second since perihelion, that's a total mass loss of billions of tons. For an object estimated to weigh 33 billion tons, that's about 10% of its total mass loss in just 2 months. A comet that naturally loses mass that quickly should be undergoing significant changes. The nucleus should be visibly shrinking. Its activity should be flickering and oscillating as its internal structure breaks down. But none of that is happening. Let me know your thoughts and theories in the comments, and please like and subscribe to the channel to keep up with the next developments.